Wow, this is a really good session. So once more, I have made these properties private to encapsulate it well, because that was the part of the homework. And then I actually generated the getters and setters below like this. So then next, from this other class, I'm having a problem because these properties are private right now. So I have to change it to using set and get. So how to do that for the array? That's actually kind of funny. Let me show you that. So I have to go tournament, and then I'll have to say get teams, like this. And then actually I have to refer to an array, because it's get teams, it's actually an array object. So instead of having to say tournament get teams, I think I could go like this. Yes, so it's a bit of an ugly syntax, but I'm saying get teams, and the zeroth element, change it into team. And team I created up there, the Superheroes International. So I'm going to do the same here. Teams. Like this. And let's do that here too. And get teams and get teams. So this is how to encapsulate the tournament class. Let's do one more. Let's do the team class too. So you see I have a bunch of properties here, and I'm going to make these private because that's step one. There we go. And then I'm going to generate getters and setters. Alt insert. I'll go to getter and setter. I'm going to select all and hit OK. So you can see there are related problems, and they're probably in this app class again. Yes, so you can see that name here is a problem now. So here I have to say set name and change that like this. Set status. Change it to this. Same here. Set name. Set status. There we go. Then for players here, it's going to be similar to the set teams we did up there, because players is also an array. So I'm going to say set players, insert the new array there, and then t.get name, and here I'm going to get players like this, and here it's the same get players. Yes, and you have to do that for all classes to encapsulate all classes well. Then I said something else, create two teams, one of type professional and one of type amateur. So I'm getting a question about this syntax. Yes, this is weird, right? Because I'm saying get teams, and if I'm going to have a look at this tournament class, and the get teams method should be somewhere here. Yes, so this get teams, it's returning a team array, and I can access elements of the array with these square brackets. So after get teams, it's basically an array, so I can just use the array on it. So isn't it set players? No, in set players, I'm inserting the new array like this, set teams, and just putting a new array in there. And then here I'm grabbing the array I just made, and I save two teams of tournaments. So I'm getting it back, and then I'm accessing the zeroth element and the first here. On line 29, very likely, t.getPlayers. No, isn't it set players? Yeah, that would make sense, right, Leon? I understand what you're thinking, because I am setting a value here, but I'm actually not changing the whole array. I'm just accessing the ith value of the array and inserting a certain value in there. So I'm getting the reference to the array object, and with this, I'm actually still setting a value to this array. Let me run it so you can see it. It's definitely a weird syntax. And actually, we'll see a better way to do this next week, because then we'll see collections and we'll get rid of all these arrays and replace them with proper lists. So they're really set. Look. Yes, finally. It's definitely good to have the next week's session. Yes. All right. And then I said create 2 types of themes, professional and amateur. So let's just create a new class. Professional team. And they extend team. I'm going to create a amateur team. Yes, like this. And it's going to extend team as well. So I've created 2 child classes here from team. And well, amateur teams, they clearly have different things than professional teams. Like a professional team, they probably have a proper budget and stuff. Something that the amateur team is less likely to have. Yes, so this is a subclass indeed, Daniela. Yes, really good. And then I said apply inheritance where it improves your code. Well, honestly, I think this is kind of it. Did someone come up with another place to apply inheritance? No? For player and coach, yes, you could have made some sort of person superclass there. So you could have said person, because a player and a coach, they have something in common. They're both people. So that would have made some sort of sense. You could have done that, yes. But I'm choosing not to do that right now, but I wouldn't be wrong if you would. Any other questions about the homework? No? All right. Let's move on to this week's content then. Okay, just double check. Are you seeing the PowerPoint? Yes, good. So this week's menu: constructor, static, and abstract. They're actually a bit of random topics just grabbed together because we have to discuss them at some point. We did this. Brings us to constructors. We have actually used constructors already. They are the sort of special method that we execute when we create a new object. So for example, when we said dog D equals new dog, the second new dog, this dog thing, this is actually referring to the constructor of the class dog. And we use it to initialize the values of a class, and we actually don't need to write one to have one. That's kind of special, right? So if we don't write a constructor ourselves, Java provides one for us. This is the so-called default constructor. Yes, I can repeat the example, or even better, I can show an example. Actually, this is not really an example. Let's move on to IntelliJ instead. There we go. So we are having a dog class over here, and here we can say dog D equals new dog. And this thing over here is calling the constructor of the class dog. But we did not define a constructor for dog yet, or actually I did because the coding examples aren't here, but let me get rid of those. So no constructor in the class dog. But if we were to run this, let's run this. Does it say? Oh, I'm apparently at some place. Let's see. No, this one has default constructor. Oh, haha, there's a constructor here. So since there's a constructor here, Java is not providing a default constructor for us. So try again, run. Okay, let's try again. 3 times the charm, right? But this might actually be the 4th time anyways. So let's have a look at our dog class. So this is our dog class that we wrote. But if we look at Java's compiled dog class, there is a default constructor in there. So if we don't write a constructor, Java adds a constructor for us. And whenever we say new dog, this thing is being called. So this invisible constructor. So let's move back to our dog class. So as soon as we provide our own constructor, so let's do that. So we are going to write public dog like this. Java will no longer create it for us because we created one. But also if ours is a bit different from the one Java is making, it still won't provide the default constructor for us. So this constructor is not taking any input arguments. But as soon as we make one that is taking input arguments, there is no longer a constructor with no arguments because we've written one. So let's call our dog Java again. Close this. Maybe let's just get rid of this for now. There we go. Yes. So now we only can create a dog when we provide a name for the dog. Because I have just decided that the constructor of dog has to have a name. And in this constructor, I could say this.name equals name. Oh, wait, I don't have a name here. Okay, so then I can say set name, name. So let me put a breakpoint on here and debug it. With debugging, the program is going to pause as soon as it hits this line. And then with these arrows, I can actually go to the next line. And I'm going to use this one to see what's going to happen next. And if I click on this one, something funny is happening. It's going to the constructor of animal. And then if I click it again, it's going back to the constructor of dog. And then if I click it again, it's setting the name of the dog. Well, that's good. Click it again, done with the constructor, back in my main methods. And then if I click one more line, you can see that now I have a dog object here. So the constructor has created the object dog. And click a few times again, the application is done. So this constructor is used for creating objects, and you can write your own constructor and give it arguments. And with these arguments, you can set the variables of the class. So that's really cool, right? And we also saw something weird, that when we created this dog that was extending animal, we were going to the constructor of animal. So there's something happening in the constructor that we cannot see. And that is the following. If you don't add something to a constructor, yes, it's implicitly doing this, calling super, and super is referring to the parent constructor, the no arguments constructor of the parent, to be more precise. So I could call another constructor as a first call. I could call super with an argument, because there is a super that takes a name in the parent. And if I do this, and I'm going to debug it again, you'll see that's going to a different constructor in the parent. Step into it. Yes, so it took this one in our previous example, and right now it's taking this one. So if I'm doing this, it's going to set the name to Java, and we're back in our dog constructor. And then we're back in our main, and we're done. So constructor is always calling another constructor as the first call. Then there's one more rule to that, and that it can only be the first call of constructor that's calling another constructor. So you cannot call two constructors from one constructor, because it can only be the first call, and well, only one call can be the first call. Does that make sense? What is the goal? That's a good question. So what we can do with this constructor, well, first of all, we are creating the object, which is great. I'll answer that in a second, Leon. But what you can also do, you can set all the properties using the constructor. So if we look to our dog object, we can actually create a new constructor here, like this, and then say it's also taking a double weight, and it's also taking a string color, like this. And then we can say this dot weight equals the input weight, this dot color. And referring with this, I'm referring to the instances property, color, like this. So now I have two constructors, and I can actually create a dog and set all the fields in one go. So let's have a dog that's, I don't know, 20, that's a bit heavy dog, 20 kg. And, well, maybe it's black, like this. So if I run it again, oh, I should have debugged it. Let's debug it. Yes, so I'm going to this constructor right now. But what I could also do, instead of referring to super, I could also refer to another constructor from the same class. So let me show you that. So instead of super, I could have also said this. And then from this constructor, I'm going to this constructor. And from this one, I'm actually going to this one. That's kind of cool, right? Yeah, so with the constructor, you can actually force fields to be set upon creation. So if I only have a constructor that's taking 3 arguments, whenever you create a dog, you'll have to provide 3 arguments. And if you don't, you cannot create a dog. So you can avoid fields from being set to null this way. Does that make sense, Daniela? Yes, then one more side note. A constructor is not returning anything. So if you see a return type and then the name of the class, you're just using a very, very bad name for your method. Because this is a method and these are constructors. And you can see this by looking at the return type. Does that make sense? Good. Brings us to static and non-static. So the static keyword, we have seen it already because the first method we use is actually static. Public static void main. It's a static method. Well, what does that mean? It means that a method belongs to a class rather than to the instance. And same for a field. If a field is static, the field belongs to the class rather than to the instance. So what do I mean with that? Well, when we create objects, like saying new dog, we have an instance. And we can call methods and fields that are part of that instance on it. But when we don't have an instance, but we just have the blueprint of the class, so to say, we can actually call methods on that too when they're static. And this is really useful because when we want to access the main method, we don't have a Java application yet, so we cannot create objects yet. So we would never be able to access anything that wasn't static in the beginning because we wouldn't have an object yet. So static belongs to the class and non-static, so no keyword belongs to an instance. Well, this actually means that in static methods, you cannot refer to non-static stuff because you're not sure you're actually having an instance when you're in these methods. because they belong to the class and not to the instance. They don't know anything about the instance, so they cannot access the properties that are not static, and they cannot access methods that are not static. And if you do that, you'll simply get a message saying non-static method in static context or something like that. So here you see an example. I've made two static properties in dog to show, well, to demonstrate how static is working. And the first one was print dog data. That's just printing something general about the dog class. And I had dog's worst enemy because I thought, well, this could be static because it just belongs to the species of dog rather than to one instance. So you can see when I'm calling the instance of a dog, I don't see these methods. But when I'm calling the class, I do see these methods, and I don't see all the instance methods. Does that make sense? Yes, I see you guys nodding. That's a good sign, I guess. I have a video that's going to be explaining this in more depth, so you can look at that to get a better view. And there's also some links to some articles that explain this in more detail. So, abstract. Well, we can use abstract on classes and on methods. So when we use abstract on a class, this actually means this class cannot be instantiated. So when we have an abstract animal, we can no longer say new animal because we cannot make an instance of this animal because it's abstract. Abstract pretty much means it's too vague. So you cannot instantiate something that's too vague. And that's a good thing, I guess, because if I would ask you, hey, I'm coming over to visit you, can I bring my animal? Your first question would probably be, what animal? You would not be able to make a decision yet, even though you know it's an animal, it's not precise enough to decide whether I can bring it, yes or no. Unless you're against all animals, then you can still answer it with no, clearly. You can also use abstract on a method. So when you have an abstract method, this actually means that this doesn't have a body. So the syntax is like this. You have public, abstract, and you have void, and then some method name. And then after the input parameters that might be there, you don't get the curly brackets, but you get a semicolon instead. So I see that on my slide there is a slight error here because this is missing the keyword abstract. Because you would have to provide the keyword abstract in an abstract class. In order to have an abstract method, you must have an abstract class. Because you cannot instantiate a class that has an abstract method because parts of it are too vague still. So this whole class must be marked as abstract in order to be able to do that. Does that make sense? Yes? Let me show you some code snippets that are showing this. So we have the public abstract class animal over here with one public abstract void eat method. And as you can see, after this method definition, it has a semicolon. Then we have a class dog over here. It's extending animal. And this class, this extending animal, it actually must implement all the abstract methods. So here we're saying it's using this annotation at override. We have not seen this yet, I think. Have we? No, we haven't. But it is to indicate that the parent also has a method, has that method, but that the child class is having a different implementation. You honestly don't need to use it, but it's preferred to use the at override whenever you can. So, and then we get the public void eat string food, and then in dog we see that there is a body, it has curly brackets, and it's doing something. And then here in the main, I'm just showing that you really cannot initiate an animal because it gets red underlined and it tells you that it cannot instantiate an abstract method. Any questions about this? Some people are typing. No questions? Oh yes, there's a question. So the last class main, I don't understand. So this one over here. Yes, so you cannot say new animal anymore because animal is marked abstract. So it's too vague to make a new animal. But you can say animal, something else, some other name, equals new dog. So you can have a reference type of animal, but you just cannot instantiate the animal. So you can have the polymorphism with the animal type, but you cannot create a new animal any longer. Does that make sense, Daniela? Yes? Good. All right. Do you have questions, Leon? I'm looking at you, so you can just simply nod or no. Good. Then I'm actually done for today already, because this is it. These are just the three topics of this week. The idea is that, again, you're going to have a look at the clips I've posted on video on YouTube. And then in the comment section, you'll find some links to external materials that I would really recommend you to read. And then it ends with a homework assignment, so you can get some hands-on experience with abstract constructors and static. Yes? All right, then you guys can all go back to trick-and-treating, I guess. No? No, me neither. No. Good. Okay, wishing you a nice evening and see you all next week. Bye-bye.